Okay. So that the SOL, the standard says that we should learn how to solve these algebraically or graphically. And by graphically, it means you're going to use a calculator. It has to be. So that's why we're doing that. So there'd be two different kinds of equations to solve. If you're given a fraction on one side equals a fraction on the other, then you can cross multiply. But if you're given a fraction on one side and the sum of fractions or a difference of fractions on the other side, then you can't cross multiply. You have to do something first, right? So if you have this kind of problem, then cross multiply. And that when you cross multiply, you get rid of all the denominators. So it's not really a rational equation anymore. And in this case, like I said, we'll learn two different ways you could solve that. Most of these things that we've done in the last couple of classes, there's like two ways to do it. You don't have to remember both ways. You just pick a way that works for you and stick with it. Another phone. No. Yeah. Okay. So if it is a fraction equals a fraction, a rational expression equals a rational expression, also known as a proportion, right? Then you cross multiply and solve. Whatever is left, you solve. It could be something that's linear, meaning all the x's to the first power. That'll be pretty easy, right? It could be a quadratic. You might have to use quadratic formula or factor or something like that. Just whatever's left, you solve it. And then you need to check your answer, because like other kinds of equations that we've solved, you can get extraneous solutions. Remember when we just did radical equations? If you checked your answer and you got the left-hand side didn't equal the right-hand side, then you said that was extraneous. Here, when you check your answer, it's extraneous if the answer you plug in actually makes one of the denominators 0. Then it's extraneous. And that can happen. Good. All right. So, example. That is a proportion. It's a fraction equals a fraction, so you can cross multiply. You remember what it is to cross multiply, right? It means this numerator times this denominator equals this numerator times this denominator. 3 times 4x plus 5 equals 9 times x plus 1. A lot of times students try to cross multiply in all the wrong places. Like anytime you see a fraction next to another fraction, you think cross multiply. But it's not when you cross multiply. It's only when it's a fraction equals a fraction. That's when you cross multiply. When did you cross multiply in the past? Do you remember? Say again? In geometry? You did probably in geometry. You set up proportions when you did similar shapes, right? And then what about when you did percentages and things like that? Way back, whenever you did that. Those are usually set up as proportions and you cross multiply to solve. Thank you. Okay, simplify. Subtract 9x. Subtract 15. Divide by 3. Remember, there's a last step is you should plug that into the original equation. Make sure it didn't lead to any divide by zeros. Right? Negative 2 plus 1. No. 4 times negative 2 plus 5. No. So you're good. Okay. So try to do the same thing with that one. So it should have been negative 3. Now, check it. Does it lead to a divide by 0 in either one of those? No. 5 times negative 3 minus 7. Neither one equals 0, so you're good to go. Okay, try that one. All right, cross multiply. You did the cross multiplying correct. You've multiplied to get the x squared. It was a quadratic. Now, that's where half went one way and half went the other. But remember, quadratics, you need to get everything on one side, 0 on the other. And then that, luckily, had a common factor of 2. So I factored it out, but I could have just divided it out, right? It's not going to be part of the solution here. X squared minus 3x minus 4 factors, and that makes the solutions positive 4 and negative 1. And it doesn't look like either one of those is going to make these denominators equal 0, so there's no extraneous. Okay. If you have more than one term on one side of the equal sign, then you're not going to be able to cross multiply right away. But what you can do is you can add the two terms that are on the same side like we did in the homework last night. And then you will have one fraction equals one fraction, so you can cross multiply. Okay. Pretty much good with that. Okay, so for example, in this problem, I can't cross multiply right away because there's two terms being added together on the right-hand side. But I can try to add them up. I would first need to know, There's no factoring to do, right? All the denominators just have one term. But what is the LCD of these two? Yeah, 4x. So what do I have to multiply the first fraction by so that it has the LCD? 4 over 4. And what do I have to multiply the other fraction by so it has x over x? So now here's my new equation. 9 over x. Yeah. Yes. That's good. 9 over x equals 20 plus 7x. I'll call it 7x plus 20 over 4x. And now we have a proportion, so you can cross multiply. So when I did that, I ended up with quadratic again, and I subtracted the 36x to this side, and now I've got to solve that. How do I solve that? Hint, factor. What's the common factor? There's an x, right? I mean, notice it's not a trinomial, right? It's not something we need to do like which numbers multiply to this and add to that. We don't have to do all that. There's a common factor of x, which if I factor it out, I have two linear factors, so I can solve this pretty easily, right? What is the solution? What's the solution that comes from this standalone x? 0. And what's the solution that comes from 7x minus 16? 16 over 7, okay? Now, check for extraneous. What if I plug in 0 into the original equation? Forget about the blue marks that I put in there. Would that be okay? It would not, because you divide by 0 here and here. So that's extraneous. Right? So this is extraneous. Right? Because divide by 0. The 16 over 7, any problems with that? No. Right, the zeros of the denominators were a 0. That was it. And that ended up being one of the solutions. Okay. So try to do the same thing with that. And what did you get? Right, so the LCD between these two was 2x. So you multiply this one by x over x, this one by 2 over 2. Now I've got, in the numerator, 7x plus 6. In the denominator, 2x. Okay, if you need to, put a 1 underneath the 3 so you can cross multiply. And then you solve that. Okay, let's do the same thing with this one. Before I can find the LCD on the right, I got to factor that one denominator, right? How do you factor that? Right. So this is x minus 3 equals 8x squared times x plus 3 times x minus 3. Minus 4x over. Okay, now just considering these two terms, right? The LCD is between these two. X plus 3 times x minus 3. Right? This one has both of those. This one has the x plus 3. So the LCD is that. Okay, what the first fraction, it already has that common denominator. So I don't have to multiply times anything. How about the second fraction? I got to have x minus 3 here. All right, so now I've got 6 over x minus 3 equals, and this here is 4x squared minus 12x. But now that is all being subtracted here. So when I put all that together, it's going to be 8x squared minus 4x squared plus 12x. And then that can be simplified. 6 over x minus 3 equals 4x squared plus 12x. And you know what? When I cross multiply, I really need to simplify this anyways. But we know x plus 3 times x minus 3, that's the factoring of the difference of squares. So let's just go backwards and make that x squared minus 9. And now we can cross multiply. 6 times x squared minus 9 equals x minus 3 times, I don't have enough room here, for x squared plus 12x. That's terrible. Okay. See if there's some way to get more space out of this. I'll tell you what I'll do. I'm going to move it down. So this will be 6 times x squared minus 9 equals x minus 3 times 4x squared minus plus 12x. Okay, 6x squared minus 54 equals, and now we have to FOIL, 4x to the third minus, I'm going to do the 2 steps here, minus 12x squared, and then it's going to be plus 12x squared. So they cancel. And then the last negative 3 minus 36x. Does that look right? I guess. Okay, let's try this. So we need to get everything. The negative 3 times positive 12x. There. Okay, now this seems like 0 equals 4x to the third minus 6x squared minus 36x and, okay, plus 54. So how do you solve that? Dave? Yeah, you could do that. I mean, I could tell you it's factorable. Because remember, if you have 4 terms, you should always think in terms of grouping, right? And if it's going to be factorable by grouping, it should be that when you look at the pattern here, look at 4 to 6, that's like 4 times 3 halves is 6. Okay, what happens over here? 3 halves times 36. Well, half of 36 is 18. 18 plus that is 54. Yeah, this is going to work out. But it could be made even easier, like Gabe said, if I divide out a 2. And I'll just divide it out. 2x squared minus, no, cubed. I'm doing terrible here. 2x to the third minus 3x squared minus 18x and plus 27. Okay, then we'd have to group. 0 equals x times 2x minus 3, and it'll be minus 9 times 2x minus 3. Yes, she's right. There should have been a squared there. Okay, so this factor is like 0 equals x squared minus 9 times 2x minus 3, which is x plus 3 times x minus 3 times 3x, 2x minus 3. Okay, so x equals what? 3 halves. Okay, now we got to check for extraneous. Okay, check these answers here, up here. Any extraneous? Both the 3 and the negative 3 are extraneous. I'm trying to think. We're going to do that one again, but in the other method, and it's not that complicated. Yeah. Where? Here? 4x squared plus 12x here? No, because it's minus this and then plus that. That's a plus. It was 8x squared minus 4x squared. You know. Okay, let's see. Okay, 4x minus 4x squared. I mean, here, this minus times minus makes plus. Right? The minus in front and this minus here together give you a plus right there. And then these combined give you the 4x squared. Now it's plus 12x. So I think that was right. All right. The other option is, instead of having to do that, which I can tell you that in this case led to us having one more solution than we needed, which was extraneous anyways. Instead, find the LCD for all the fractions. Multiply both sides by that LCD. We're not finding common denominators here. Right? What we're trying to do is cancel all the denominators. So multiply by the LCD to cancel all the denominators, and then you'll solve what's left. And we saw this on one other problem last class, not the one that we just did, because we didn't actually do that one with this method, with the first method. But on another problem, we saw where if you did it by the first method, you actually got one extra answer that you had to check, and it was extraneous. Okay. So I'm going to do the same problem, but this time I'm not going to add the 2 on the right. Instead, I'm going to find the LCD, which is the same thing, right? LCD x plus 3 times x minus 3. Okay, then I'm going to multiply both sides times that. Go back to blue. So on this side, I'm going to get 6 over x minus 3 times x plus 3 times x minus 3 equals 8x squared divided by x squared minus 9, which we know is x plus 3 times x minus 3, times x plus 3 times x minus 3. And one more time, minus 4x times x plus 3 times x minus 3 divided by x plus 3. Right? So I find the LCD. I'm multiplying both sides, every term by that. It should now cancel all the denominators, right? This minus 3 cancels with this. X squared minus 9 cancels with both of those. And x plus 3 cancels here. So in one step, you get rid of all the denominators. So we have 6 times, I'm going to go back to blue. 6 times x plus 3 equals, okay, cancel, 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 equals 8x squared and minus 4x times x minus 3. Right, so that is 6x plus 18 equals 8x squared minus 4x squared plus 12x. Now we subtract the 6x and the 18 to the other side. 0 equals 4x squared, because I combined the like terms here. 6x onto this side will give me plus 6x. And 18 to this side is minus 18. Now we still got a quadratic to solve, right? Let me divide out a 2. 0 equals 2x squared plus 3x minus 9. And that would be one of those not simple. But is it factorable? Can you look out and see that it's factorable? 2 times negative 9 is negative 18. Are there factors of negative 18 that add up to 3? 6 and negative 3. So it would work that way. Now, we could go through that long process. We could use the quadratic formula, but we actually already know the answers to this one. And I'm just going to use some guess and check here. Because the first term is 2x squared. I know I've got a 2x and an x. And I don't know for sure, but I'm guessing that the last terms are either a plus 3 and a minus 3 or a minus 3 and a plus 3. So I'm just going to play around and see whether I can make it work. And I think minus 3 plus 3. Now I get 2x times 3 is 6x. Negative 3 times x is negative x. So 6x minus 3x. That works. And so now my answers are 3/2 and negative 3. And negative 3 is extraneous. So that was the same problem we did before, but it was a lot easier this way than it was that way. Well, it was an extraneous answer when we did it the other method, which means it's not an answer. Okay. So try to do that one. Right. The LCD was 2 times x minus 1. So I multiplied all three of these terms by 2 times x minus 1. And then I cancel all the denominators. And what's left is linear and pretty easy to solve. You get -3. If you found the common denominator between those two, you probably ended up with a quadratic that had 2 answers, and one of them was extraneous. You could use either method, but it appears like this is the way you won't get an extraneous solution, or you get less of them. Now, I was going to show you something with the calculator then, okay? Because you can solve these equations. It says we're supposed to solve graphically, and by graphically means you should be able to put them in the calculator and solve them. And what it means is, this is going back to something that you did before, which was called systems of equations. Do you remember what was a system of equations? It was more than one equation, right? And where did you find the answer on a graph of a system of equations? Right? If you graph 2 lines on the same background, where's the solution to the system? It's the intersection point, right? So that's what we're doing here. We're going to turn one equation into 2 functions, right? Our equations only have one variable. They only have x in it. But we're going to take the left-hand side of the equation, and we'll put that on the first line in the calculator under y equals. And we'll take the right-hand side, and we'll put it on the second line. Now we've turned both of those into graphs, and we'll look for where do they intersect, and that'll be our answers. And this is a good method to know because it works for all kinds of equations, right? You could do logarithms, you can do exponentials, you can do radicals. Put the left-hand side on the first line, the right-hand side on the second line, and follow these steps, and you'll have the answer. Okay. Now, at this point, it just turns into a bunch of, here's more stuff to memorize, you know, but this time it's calculator procedures. But, you know, I'll show you all this stuff on your calculator if you're not that familiar with it. I mean, one thing you might want to do, just so that you are all operating from the same place, you might want to clear the memories. Do you know how to clear memory in a calculator? Second plus 712, right? These, because they're 80, you may have used 83s in the past that were second plus 512, but this one has more options in that menu. So it's second plus 712, and now everything is clear, okay? Right. We'll do one on the next slide, but we're gonna go to the y equals. Where is the y equals on the calculator? Top left. Right? And you'll see there's a whole bunch of y1 equals, y2 equals, y3 equals. We're going to put the left-hand side on that first line. We'll put the right-hand side on the second line. And then, if you look in the calculator along the top, where it says trace, right? What does it say? Right above the trace, it says calc. So we're going to go to second trace, and look at number 5, that's intersect. So that's how you find intersection points of 2 graphs. Now, if you want to use the calculator to find intersection points, the intersection points have to be on the screen, right? It can't be like off the screen. It's not going to find that. It'll find them if they're on the screen. You know, we're not going to run into that today, but if you ever do, understand that you can go to the zoom menu. Right? Zoom is right in the middle on the top, and zoom out. Zoom 3, enter. And then it'll pull back and you'll get more on the screen. And it pulls pretty far out, right? I mean, you could do it 2 times and then it's like from outer space. I mean, you can't see what's on there, but the calculator knows what's on there. And, you know, sometimes you have to move the cursor on the screen to the left or the right to get to the portion of the graph you want to be in, especially if there's vertical asymptotes involved. So we know that there are because these are graphs of rational functions. So we're going to solve this one right here by using this method. So again, hit y equals, so that you've got your y1 and your y2. And then I've got the left-hand side on the first line and the right-hand side on the second line. Now, if you want to enter as fractions, then you do this. Alpha, y equals 1, right? Alpha is right there. Y equals, and it's bringing up a little menu there. Hit 1, and it'll bring up the fraction format, so you can enter it as a fraction. No parentheses needed around the numerator and denominator, because it's already a fraction, right? Is anybody needing help to see that? Now, the other thing that I like to do when I'm putting more than one graph, or more than one curve, which we'll call that, on the graph, that I like them not to look exactly the same. So if you want to have the second one have a fatter line to it so it's clear which graph came from which function, then you move the cursor all the way into the left margin so it's blinking over that, and then hit enter once. And it'll change that thin line to a fat line so that when you look on the graph, they're different. How are we doing? You okay? So what does it say in those directions I gave you? After that, then we're going to go second trace 5, right? Do exactly those steps. And what you'll see the graph, right? You can see the thin line is here and a little bit here, and the fat line is there. And it should say first curve, and it should be that the y is blank. Is that what you got? Okay. So at this point, if you try to hit enter, it can't do anything because it's not on a graph yet. Because that's blank, it's not on a graph. Now be precise here. Hit the right arrow once, just once, to move it to the right. Right now it's set at x equals 0, which is right there. Move it to the right 1, just one little touch. And then you should have a y value, right? It should be x equals 0.2127 and y is 4.89. I mean, you could have moved over farther. You could have. Just so that we all get the same answer the first time. Okay, now it's definitely on the graph. It's this one right there. So you just hit enter 3 times. Enter, enter, enter. And you should get the intersection, -2, -3/4. What'd you get? Okay, because you moved over more than just one click when you did that. So there was 2 answers here. There's an intersection point here, and there's an intersection point over here. So if you moved further over towards that intersection point, it found that. Or if you just moved 1 click to the right, it still thinks that that's the closer intersection point. But if you move farther over, then it found this point. That's why I said if everybody just does 1 click, we'll all go to the same one. So if you repeat those steps, right? Second trace 5. If you want to see whether there's another intersection point, like in the place where you didn't already find it, then move the cursor closer before you hit enter, and it'll jump to the other solution. So I got -2, which is there, and you got 3, which is there, and that looks about right. Now, understand that there's an x and a y coordinate to those points. When you solve systems, the solutions are points, right? But we introduced the y. There's no y in this here, and we don't care about the y. We just want the x coordinate. That's the solution. And I think that's about all the time we have to give to that today because we got to take a quiz, remember? But I just wanted to see that when you get this, this is the way to solve a non-multiple choice rational equation on the SOL if you don't remember how to do it in the other ways that we've done.